Okay, so clearly I really cannot be in class today. Um, so back to where I was. Centrifugal force and its uses. The video we saw back on Thursday, was one, here it is here for the URL if you need to remind yourself. There was one looking at a motorcycle followed by a car driving around the quote-unquote wall of death. This is a cylindrical arena that has nearly vertical walls. First the motorcycle and then the car drove up onto it so that the car was driving essentially vertically on those walls. And the question I left with the other day was, well, so what keeps the car on the wall? So we have a couple of ways we can think about this. This is our top-down view. And this would be a side-on view. So in this view we are, say, a drone flying over the wall of death. The car is going around the circle in this direction and we're seeing it from the top. Its wheels therefore are here and here. In this viewpoint we have sliced the arena. One of the walls of the arena would appear as a line here, but I'm not going to draw it in because that will make our drawing more complicated. And we have the car going into now the plane of the board, I guess, with its with its wheels. Let's see here, here I guess, and here, but now we're looking at a different set of wheels. Okay, so how are we understanding what's going on with the car? The car has on it, as we understand, I'm going to draw it on the side view now because that way gravity is in the correct or sort of usual direction. We have the force of gravity down on the car. And then what else do we have? We have a question. We don't know what's keeping that car on the wall. In the centrifugal force frame, it's pretty easy to explain. In the centrifugal force frame, from the point of view of the car, then there is a centrifugal force on the car pushing it this way. I'm going to label it F sub CF. There is therefore a normal force exerted by the wall on the car this way. The force of gravity wants to cause the car to slide down the wall. Friction force resists the direction of motion, and therefore there is a friction force opposing the direction of motion that would be caused by the force of gravity going this way. And we can measure that friction force as being the coefficient due to the coefficient of sliding friction times the normal force, and that, as long as the car is not changing its height, being equal to the force of gravity. Since the normal force has to oppose exactly the centrifugal force, we could kind of go through this entire calculation, find, if we knew the mass of the car, we could find the centrifugal force appropriate for the radius of the arena. If we knew the coefficient of sliding friction, we could also turn around and obtain information about what that force of friction has to be to keep it there, and everything will end up needing to balance it off.